All right. Here's a simple principle, far simpler than we usually give it credit for. If we're adding or subtracting radicals, then the first thing we have to do is just simplify them as much as possible, so simplified mixed radicals, and as long as the index and radicand are the same, I can just add the coefficients. So if I'm thinking of why that works, think of it this way. In my first example, if I had the square root of 7, and I just called it x, well then this would just be 2x plus 13x, and I would just combine the coefficients. So as long as it's both the square root of 7, they're actually the same number, which means that they're both x. So in this case, I'm just going to say that it's going to be 2 plus 13 is 15, and the square root of 7. For example B, I need to simplify it first. So you can use your simplifying method, whether you're factoring it down or dividing by a perfect square. And then I'm just going to say that this is going to wind up being 2 and the square root of 6 minus the square root of 6, and it's just going to give me the square root of 6. Now, when I get to C, still the same idea, I just need to simplify them all separately. So, for the first one, I'm going to simplify that 54 and then multiply the coefficient that I get from there by the coefficient that already exists. So I'm going to say that in this case, if I simplified it, it would be 4 and then 3 and the cube root of 2. And I just need to remember to multiply the 4 by 3 to get 12 and the cube root of 2. My next number doesn't have a coefficient, so I'm just going to say that that is going to be 5 and the square root of 2. The next one does have a coefficient again. So if I have this negative 5, and then I simplify just this part, I'm going to wind up with 3 and the square root of 2. And when I multiply the negative 5 by the 3, I have negative 15 root 2's. And for the last one, it's just going to be 2 and the cube root of 2. Now, once again, I'm only combining like terms. And here I have the cube root of 2 and cube root of 2 are like terms. And the square root of 2 and the square root of 2 are like terms. So I can say that if I have 12 cube root of 2 and 2 cube root of 2, I have 14 and the cube root of 2. If I have 5 root 2 minus 15 root 2, I have negative 10 root 2's. For example D, when it adds a variable, it doesn't really change anything. The variable isn't squared or anything, which means it's going to stay inside the radical. I'm just going to simplify these as much as I can. So for the first one, I'm going to say that's going to be 2 root 5x. For the second one, I have minus 3, and then this is going to simplify to 3 root 5x. So I have 2 root 5x minus 9 root 5x, or negative 7 root 5x. Example E and F work the exact same way. So I'm going to start by simplifying these. I'm going to say that this is 5 and 2 root 2 minus 3 and 3 root 2 plus 2 root 3 can't be simplified. I have 10 root 2 minus 9 root 2 plus 2 root 3. And as we can see here, the root 2 and root 2 are like terms. The root 3 is not. So I can't combine that one in. It's just going to stay a separate term. And my final answer is going to be square root of 2 plus 2 root 3. When I get to example 4, I'm going to do the same thing. I'm going to start by saying I have 4, and then the cube root of 8 is just going to be 2. The x squareds, well, I don't have at least 3 x's, so that's not going to work. The y to the 4, I have 3 y's and then a y left over, so I'm going to say 2y, and then the cube root of x squared y. In the second one, I have negative 2, and then when I pull those x's out, well, if I have 5 x's, I have at least 3 of them, so I take 3 of them and take the cube root of that, which is just going to be x. And then after I took away 3, I'm left with 2, and I have my x squared y. So what I actually have is 8y and the cube root of x squared y minus 2 x and the cube root of x squared y. And these ones, unfortunately, I can't combine because even though the radicands and the indexes are the same, they do have different variables on the outside, so I can't actually combine those variables. Alright, if I'm actually applying it, this is a very popular way of applying these things, where if I'm just dealing with perimeters, because typically when we have triangles, not all the sides are going to wind up being exact. Usually you are going to have irrationals or values that we're going to have to round. And because we don't like rounding so much, now we're going to use the exact values. So in this case, if I'm trying to find the exact perimeter, I'm taking this side plus this side plus this side. Well, that root 3 is already as simplified as possible. And then I'm adding to that the square root of 12 and the square root of 27. Well, the square root of 12 and the square root of 27 can both be simplified. The square root of 12 is going to be the same as 2 root 3, and square root of 27 is the same as 3 root 3's. And because they all have the same radicand, same index, this is all going to be 6 root 3 meters when we combine it as exact values. Alright, and the last example. A square is inscribed inside of a circle. The area of the circle is 38 pi times m squared. What is the exact length of the diagonal of the square? Well, when I'm talking about the diagonal running from here to here, because that runs the entire length of the circle, it's really just asking what is the diameter of the circle. So, if I know the area, which is the same as pi r squared, then I can say if 38 pi is equal to pi r squared, then I divide both sides by pi, and that's going to cancel out. And if r squared is equal to 38, then r is equal to the square root of 38. If diameter is double what r is, the diameter is equal to 2 and the square root of 38. Now, if I'm trying to figure out the exact perimeter of the square, well, this has to be a 90-degree angle, which means that this is going to be my hypotenuse. If c squared is equal to a squared plus b squared, and in this case, a and b are equivalent, then I could say c squared is equal to a squared plus a squared, or c squared is equal to 2a squareds. So then I can say, well, I'm going to state that 2 times the square root of 38 squared is equal to 2 times a squared. When I square this, just be careful, I have to square what's on the outside, which is going to give me 4. And when I square the radicand, well, the square root of 38 times 38 is just going to be 38. The square root of something squared is opposite processes, and they're going to cancel out. And I can say that 4 times 38 is going to be 152 is equal to 2a squareds. I divide that by 2. And I'm going to say that 76 is equal to a squared. And I'm going to say that a is equal to the square root of 76. Or 2 root 19, if I want the simplified version of that. If it's asking me for the last part what the perimeter is, if perimeter is equal to 4 times the side length, then the perimeter is going to equal 4 times 2 root 19. The perimeter is going to wind up being exactly 8 root 19 meters. And there's my answer. All right, try some of the assignment, get some practice done.